This video is going to cover the topic of experimental probability. Be sure the date and topic are at the top of your page. The essential question that should be at the top of your notes is, what is experimental probability and how is it different from theoretical probability? We've already talked about theoretical probability, and I'm just going to remind us of what that is here. We talked about theoretical probability being how likely something should happen. For example, when we flip a coin, right? If we have a coin that's heads on one side and tails on the other, there are two outcomes. They're equally likely, so we should get heads as one of our outcomes, right? About half the time. One out of every two coin flips, we should get heads, right? That's our theoretical. However, sometimes we can't predict what will happen, or we need to rely on looking at data or doing an experiment for ourselves, and that's when we use experimental probability. And just like theoretical probability, experimental probability is something that we show as a ratio. This ratio is the number of times something actually occurs, right? The outcome we're looking for occurs out of the total number of trials. And I'm going to write this in fraction form as well. So you can see kind of the big difference here is that this is out of an actual set of trials, right? You're actually doing this, you're doing the experiment, hence the name experimental probability. It's not in theory, it's happening in real life. One thing to keep in mind is that experimental results can be different than our theoretical predictions, but something fun is that the more times you do an experiment, it should get closer to theoretical. Let me show you a quick example with our coin flipping. We know by now that the theoretical probability of getting a coin to land with heads up should be 1/2, right? There's two outcomes, one of them is heads, they're equally likely, so it should be 1/2. But if I actually do this, if I flip a coin 10 times, I might not get half of the turns to land on heads. In fact, I just did this here, and it only landed on heads 3 times, but I performed 10 trials. So my experimental probability, if I actually write out my ratio, my desired outcome happened 3 times out of a total of 10 trials. So even in theory, it should have been 1/2, right? It wasn't. And we'll try this in class, but what you might see is that the more times we do it, I only did it 10 times. The more times we do it, the closer we might get to having half of our results being heads. Over time, our experimental probability should get closer to our theoretical prediction. So this is the first thing, right? We know that one thing experimental probability does is lets us record what actually happens when we run an experiment. So we can actually just kind of put out there what the results were. But experimental probability can also be used when we can't actually make a theoretical prediction. And that's because some things are not as straightforward as heads or tails, right? Or choosing marbles from a bag. Sometimes events are unpredictable because humans are not machines, and we might be doing something that we want to make predictions on, but we don't know exactly what we'll be able to do. So in those cases, we can look at what has happened in the past to make our prediction from the future or for the future. I'm going to use an example about a basketball team. Maybe I want to predict how many points my team might get in their next game, but that's not something I can really use theoretical probability standards to do, right? So what I can do is look at some past results. So I made a table here of 8 games and the points that the team may have scored in each of those 8 games. And I can use this as my experience to kind of predict what will happen, right? And this is an experimental probability use as well. Maybe I want to see what the probability is that this team will get at least 30 points. And I've recorded it here with my symbol, greater than or equal to 30, right? I want to have at least 30 points. Well, if I look and I make a ratio here at the number of outcomes that meet what I'm looking for, right? The number of outcomes that show what I want, I can see that there are, let me switch colors here, 1, 2, 3, 4, 5, 6 times, right, that met that stipulation, so at least 30 points, out of the total 8 games that they have played. So in the experiment that I'm looking at here was that 6 out of 8 times they scored over 30 points. So that's a pretty good prediction of what might come, right? 6 out of 8, or I could say 3/4. Right? So I have a 3 out of 4 chance in my next game of getting more than 30 points, or getting at least 30 points. And of course, this is just a probability, right? I can't say for sure that the team is going to get at least 30 points, right? People are unpredictable. But if I had to make a prediction, I would say it's pretty likely, right? 3 out of 4 is pretty likely that they'll have at least 30 points. So this video was about experimental probability, and it's different than theoretical probability because it might involve us recording what happens in a real experiment, right? Which we can't do if we're just kind of making a prediction from theory. And also it can be used when we can't make a theoretical probability, when it's based on something that doesn't have a concrete result like heads or tails, right? So we saw that with our basketball example as well. So make sure you have your notes available with you when you come to class. Have any questions that you might have, and we'll do some experimental work together in class.